Now see a moving coil galvanometer. You know the galvanometer is a device which is used to detect current in the circuit. Even a small current can be detected by a galvanometer. So see here how does galvanometer work and what is its principle. So now see here the working of the galvanometer and its principle. So we have seen when a rectangular coil carrying current is placed in uniform magnetic field, it experiences torque and it rotates because couple acts on this, and this principle is used here for making galvanometer, moving coil galvanometer. So now see here there is two poles of the magnet like a north and south. These magnets have been given here concave shape to provide radial magnetic field. So because of these concave shapes, magnetic field is always radial here, so that maximum torque and constant value of torque keeps on acting. There is a here the soft iron over which coiling has been done. This coiling or this soft iron core is pivoted with the help of the springs, and there is a spring that is called hair spring, which is made of the phosphor and bronze material. And now the pointer is connected to this coil here. So when the current is passed through this coil, the coil experiences torque and this coil rotates. And when this coil rotates, so obviously the pointer will be moving either this side or this side, and wherever the pointer moves or indicate, that is the reading of the current or the magnitude of the current shown by the galvanometer. Larger the deflection, larger is the current. But see here what is the use of this spring here. So this soft iron core is pivoted with the help of the phosphor bronze spring that are called also hair spring, very thin springs. So when this coil rotate, these his springs also provide counter torque, that is known as restoring torque. So whenever the torque due to electric current and the torque due to the spring, that is restoring torque due to the spring or the counter torque, we can say are equal, the needle comes in equilibrium, that comes to the rest. And also here this soft iron core is used here, where they due to the movement of this coil in magnetic field, there is the eddy currents are generated, which helps in bringing the needle or the pointer at rest immediately without any oscillations. So now let us do mathematical part. So the certain thing is here, suppose the coil has got the n number of turns, current I is allowed to flow through this coil, then the torque acting on the coil is equal to, torque is equal to, because theta is 90, that means the alpha is 90, angle between magnetic dipole moment and magnetic field is 90 degrees. So maximum torque is acting, and that can be written here MB, and that can be written here NIAB, because sin alpha is equal to 1 I have taken here. Alpha is the angle between magnetic dipole moment and magnetic field. Now let the restoring torque per unit twist in the spring be suppose K, that is called torsional constant also. Then we can write restoring torque is equal to K phi, where phi is the total twist in the spring. So now this is the formula for the torque due to current flowing through the rectangular coil, and also this is the restoring torque. In equilibrium these two are equal, so we can write K phi is equal to NIAB, and we can write phi is equal to NIAB divided by here K. So and here we can write, that is because the NAB is constant for the given galvanometer, so we can write phi is proportional to I, where the G is equal to, we can write, that is a constant for galvanometer is here NAB upon K. So if this remains constant for the given galvanometer, then the current flowing through the conductor is directly proportional to deflection. So larger the deflection, larger is the magnitude of the current. So now we have to study also here about the sensitivity of the galvanometer. This was the working, how does a galvanometer work. So sensitivity of the galvanometer. So see here this one, if I continue with this part only, phi is equal to NIAB upon K. So we can write phi is equal to NIAB upon K, and if I write phi upon I, this is known as current sensitivity, and which is equal to NAB upon K, right. So, the current for the unit deflection is known as here, that is the current sensitivity. So, larger the deflection for the smaller current, that is called the more sensitive. Similarly, we can get the voltage sensitivity Vs is equal to, that is phi upon V, that is phi upon IR, R is the resistance. So, we can take Vs is equal to phi upon I, that is already given to you NAB upon Kr. So, this is here the voltage sensitivity, this is the current sensitivity. Both are related also with each other, the Vs is equal to Is upon R. So, see here the current sensitivity of the galvanometer or the sensitivity of the galvanometer can be increased by increasing number of turns, by increasing area, by increasing magnetic field and by decreasing K. But see here, when you increase the number of turns in the coil, the size becomes bulky and resistance also increases. So, it is not advisable. Similarly, if you increase area, its size become large. So, this is also not advisable, and also the B string increasing the magnetic field B, have to use strong magnets. So, this is the best option is to increase the sensitivity here is reduce the value of K. That is why for making the springs or to reduce the torsional constant, phosphor and bronze material is used for making these type of the springs, so that the value of K is very small for them. So, this is about the galvanometer and its sensitivity. So, now let us discuss how do we convert galvanometer into ammeter or the galvanometer into voltmeter.